let's get into the big topic of open source, something that we actually say at Red Hat.
We have a
This is so
we
awesome.
are an open culture that believes in the importance of
What is that process that a developer, or let's say
as the Kubernetes ecosystem really boomed.
Hello and welcome to this week's Ask an OpenShift Admin Office Hours live stream. I am co-host Andrew Sullivan, and I'm joined, as always, by the amazing, talented, and incredible Mr. Jonny Rickard. How are you today, sir?
I'm good. I'm also, I think my new title, other than like Mother of Dragons, should also be Perpetual Issues with Audio. Like, how's it going?
It's good. You know, I had a good Thanksgiving, despite fighting through. So for anybody who doesn't know, here in the US, last week was the Thanksgiving holiday. And so I took the entire week off. It was amazing. I relaxed. I disconnected from work, except that 2/3 of the family was sick. Just who was sick kind of rotated around. So, you know, it was a thing.
Yeah, it always is.
So yeah, there's something going around right now, and like just between kids and partners, and just even the dog got sick. I mean, I got nothing. Like,
I can't win.
so, but no, it was a good holiday. It was good to see family, good to hang out with folks, and just you know, I'm clearly not afraid of a good meal, and several were had, so I will not complain about that. How was your week?
Same. I basically stuffed my face. I usually start Thanksgiving around Saturday or Sunday, and I just keep, you know, it's basically like it's an exercise to expand my stomach so I can fit as much as I possibly can in on Thursday.
It's a marathon, not a sprint.
It is. So it's actually my favorite holiday. I love it. I've always loved it, even when I was a kid. So yeah, it was good. My family is also in the rotational sickness right now. I think I started with a cold, and then it's just rolled through everybody, and they're just progressively getting worse as it hits the next person. So.
Well, we are joined today by a couple of folks from a near and dear partner to my heart. I've been working with Dheeraj and Reza for quite a while now around a number of things. And this is sort of the culmination of a lot of work that we've had between Tigera and Red Hat. And I would say I've only been doing this for, I don't know, 6-9 months, maybe something like that, since we really got involved on the virtualization side. But Tigera and Calico have been supporting OpenShift for a very long time. I think that y'all were one of the very first third-party CNIs, third-party SDNs that supported OpenShift, which is pretty amazing. So today's topic is, you know, we're going to be focusing on Calico, on Tigera Calico, and how it fits in with OpenShift and what it means in particular for OpenShift virtualization. I think Reza's got some demos that he's going to show that are just some really cool stuff where the Calico feature set works with VMs just like it does with containers, which is awesome.
Mm-hmm.
So Dheeraj, Reza, I'll ask you to introduce yourselves. We'll quickly go through our top of mind stuff, and then we'll dive right in. So Dheeraj, please.
Sure. Thank you, Andrew, and thank you, Jonny. My name is Dheeraj, and I work in Tigera as a Director Technical Marketing with Reza. Tigera, I don't know how much you know about that name itself, but what you definitely know about is Calico, which is the, I will say, largest and most used open source solution for container networking and security and network policies. And our collaboration with Red Hat has been since the start of the project and of the company and all the iterations we have gone through. And as Andrew pointed out about the support and a lot of the customers who use us for the networking and the network security for the OpenShift platform, where they are basically building their modern applications. In the process itself, the collaboration has done very well. In recent KubeCon, as you know, we announced with Red Hat the nftables dataplane support. Like, we are the first ones to come out with the Red Hat team. So as you are looking to go further from the iptables, the nftables options as enabled in Linux, Red Hat Linux, we will be the solution which will basically provide you everything about the networking and network policies, observability, cluster mesh. There are many things which we do in conjunction with the Red Hat OpenShift platform. Needless to say, there is the full Calico eBPF. So you're looking at the leading edge side of the world with respect to the networking data plane. So eBPF data plane also comes with Calico. So, and many of our customers are using the eBPF data plane with OCP itself, OpenShift container platform. But today's topic, I think so, what we have recently started to collaborate and has been of very much an interest in the market from all the perspectives of cost saving, modernization, migration, and then looking at OpenShift in a different way is the OpenShift virtualization platform, right? As people have started to look into the newer, or I will say, more open and economical open virtualization platform for their VM-based applications. Um, they have been basically moving and have a lot of talk which is going with respect to the OpenShift virtualization platform. And in that process, they are in this scenario of like two scenarios where they are able to move everything from their traditional like VMware type of environments and move over to the OpenShift platform. But then they have a lot of uh, requirements with respect to the networking as it used to work in the VM world. Aka, you can say the NSX type, like very much network segmentation, networking, pinning into the physical layer, and they are looking for the same experience in regards to this Kubernetes-based OpenShift virtualization solution. And Calico basically comes in because we were always a part of that, um, like the foundational work of Kubernetes on which OpenShift has worked. OpenShift virtualization is being built on. And the second situation where we have seen quite a bit is where many of the enterprises out there have some of their workloads, the VMs and the bare metal, still living in the VMware world, but there's a gradual transition which is happening because no one writes a pay as you go subscription model. People have yearly contracts, so they are looking at a planned migration in which some of the workloads will come into the OpenShift virtualization right away. Some of them will be in planning for the migration side, and some will remain where they are based on the cost envelope any enterprise out there is going to look for. So in that case also, Calico basically works very well. Like we provide the network security for the VMs, hosts, and the containers itself. So it becomes a single solution to help you basically get the network policies, the observability, do all the like protection of your VMs and the hosts, which are even outside the OpenShift virtualization. So Calico, when you're looking at is the evolution has gone from just being a CNI into a full-fledged platform to help you secure your VMs, host, and containers for your this planned migration, or I will say a new form of the hybrid cloud architecture. Um, in all this, what we have started to see, in addition to, I will say, the compute requirements, the storage requirements, the networking requirements are basically coming into play from the perspective of how the Kubernetes has an open communication across the board, and people are looking to basically bring the network segmentation or IP-based segmentation onto the Kubernetes side of the world. But what they are seeing is that implementation is very different, right? It is not exactly the way it happened in the NSX or the VMware side. There are no static IPs, things move around, the workloads move around, the entire profile change. And then Calico basically helps on the OpenShift virtualization side quite a bit. But there are three specific use cases in which we come into the play. Um, and I will say there is a fourth one which has started to emerge also because people have Kubernetes multi-cluster type of deployments also coming in. So the first one we see is where people are trying to get their virtual IPs or virtual traffic basically fed into their physical data fabric, and they need a tier 0 type of networking, BGP, tier 0 networking. The second one, what we see is if you have tenants within your OpenShift environment, what you're looking at now is every tenant has its own private network. That's another complex scenario we have started to see. And the last one, what we have started to see is traditional micro-segmentation, right? Like you need to have these DMCs, the zone-based architecture, which we have built over the years, exactly transferred over to this OpenShift virtualization. And rather than just going and doing it yourself, people are looking at like, okay, can I get someone who can look into all type of traffic, give us some recommendations? Then on top of that recommendations, can we get some type of staging evaluation of putting this micro segmentation in and make it entire experience of the Red Hat OpenShift virtualization and Calico basically as seamless as possible, right? And make them focus on the main thing of saving the cost and making it go faster. There are many of the enterprises which Andrew and us have been working jointly who are actively working on these things. There are discussions going on. But just to now, rather than just keep talking about it, I will let Reza show you like the claim we are making. It's very easy to get started and see how it operates. So Reza, to you. Before that, any questions, Andrew or Johnny?
No, I'll say we haven't had any questions pop up. I'll also point out, Johnny and I really didn't have much for our top of mind today, so we can also skip that. What was the one thing I was going to say? Oh, for anybody who missed the What's Next, which is the roadmap presentation, it happened on Monday this week. So just look in the YouTube channel history and it'll show up there. YouTube or Twitch, I think.
Yep. And just so you know, the first 4 minutes right now are muted because of me. And so I'm actually re-recording I'm stitching together the audio back into it. So it will be updated soon with the actual audio of the intro. So I'm so dumb.
I'd fire you, Johnny, but then I'd have to do it, and
I can't believe I did that.
No, you did great. What was I going to say? So I will take, while we have a pause, I will take a moment. So for the audience, this is an office hour live stream here with Red Hat Live Streaming, which means that we encourage and want and hope that you will ask us any and all questions that come to mind. So while Reza and Dheeraj are going through and showing us and talking about all these things, Johnny and I will be interacting with them as well as with y'all. So please don't hesitate to ask questions in chat. We'll do our best to get those answered. Even if it's not about today's topic, if it's about other OpenShift things. Johnny is an expert. I'm a manager, so I don't count. But I do know who to ask inside of Red Hat, so I'm very good at delegating and otherwise Teflon tasking these days. So happy to find and happy to identify those experts. That way we can get whatever questions you have answered. So with that, I won't delay any longer, and I will hand over to Reza. And Reza, if you don't mind introducing yourself as well.
Hello, my name is Reza. I'm a developer advocate at Tigera. Basically, I go door to door and preach Calico to people. People should use it. It's a great piece of technology. And as Dheeraj said, in KubeCon, we released Calico 329. So if you're running an old version of Calico, make sure to upgrade. There's a lot of new things that we packed for you in this new version. With that being said, let's get back to our OpenShift presentation. So there were a couple of use case scenarios that Dheeraj talked about, and I'm going to go through them one by one. These 3 use cases are usually the things that you would see when you're trying to migrate from a virtualized environment to an OpenShift or Kubernetes, these sort of environments. So with that, let's start. When you're running a virtualized environment, here I'm talking about VMware, but that's just an example. It could be anything. It could be Proxmox, Zen, whatever you have. You usually have some sort of networking, which is done by a piece of software. Again, in a virtualized environment, networking is also uses some sort of SDN, software-defined networking. In VMware, it's usually NSX if you have a big environment, which gives you things like virtualized network path, gateways, these sort of things. You usually have tier 1 and tier 2. Your tier 1 is always responsible for talking to the external networking. So usually the public area could be internet, could be some other enterprise that you need to get to. And tier 1 is usually your fortress where all other switches, virtual switches, and VMs are connected to. Now, that being said, if you're trying to migrate, it's going to be a little bit tricky because in a migration scenario, you will have new instances, and these new instances are not part of your virtualized environment. So in order to make everything smooth, you need to have some sort of communication established between these two environments. That being said, a really popular way to establish this sort of communication is BGP. So when you install your OpenShift environment with Calico, you get the opportunity to start a BGP session with your old environment. Now, in your old environment, you create an ASN identity and peer these two environments together. Then your virtual machines can talk to the other environment and vice versa. Now, that being said, there are a couple of ways that you can actually get a BGP network. Now, one is usually a route reflector, which means you will have a couple of routers in the other environment or your old environment that will be used to propagate routes to your new OpenShift environment. And in your OpenShift, instead of running all the nodes with a BGP session, you just delegate those BGP routings and propagation to specific nodes. In this way, you will have a couple of instances that are only responsible to communicate with the outside world to propagate all the routes and stuff, and all your internal, all your other nodes who are not the route reflectors get to figure out how they can access the other environment using these 2 or 3 nodes. Now, that being said, sometimes you might need a full mesh, which means you want to have like 5 nodes directly talking to the other 5 capable BGP interfaces or routers on the other side. That will be BGP full mesh. It's quite easy in Calico. In your configuration, you just set a selector, and then you can have it all. Now, there is a video somewhere. So basically, if you have your OpenShift virtual machine. Here I have a virtual machine with a WordPress on it. It cannot talk to the old environment, as you can see. Pretty standard stuff. You get the console. It's Fedora Bugs. I'm gonna first find where it's trying to communicate. This is usually in your application configuration file. Here, I want to access 192.168.0.2. As you can see, there's no ping for it, which is usually either a route problem or a policy problem. Here is a route problem. Going to the other environment, not the OpenShift. As you can see, there's a MySQL, and MySQL actually has the IP address of 192.168.0.2. Now, in the other environment, I do have a bird running, and it's trying to establish BGP with my OpenShift nodes. And here are all my OpenShift nodes. All I need to do is to create a BGP identity in Calico. This is done by using a BGP configuration. As you can see, it's just a resource like all your other OpenShift resources. The only thing about it is it uses the BGP configuration kind and the API version of CRD project calico.org, which is the API tree that everything Calico related will be stored in.
And
Um,
Reza, if you don't mind me
yeah,
interrupting, sorry, I was
go ahead.
responding in chat, so I meant to interrupt you a couple minutes ago.
Oh, okay.
So I want to level set on BGP and kind of what we're doing at a high level here, which is effectively the expectation or the thought is there's a number of customers who are using basically the networking stack and delegating management of that networking or the networking segments for their virtual machines to their virtualization environment, right? So the network or the virtualization team goes to the network team and says, hey, give me a BGP AS, which is what we see here, that AS number 65532, and a set of IP addresses, which I think is defined there on the service cluster IPs, maybe. So the network team says, here you go, here's your AS number, here is a /16, 18, 20, whatever that happens to be, go forth and do great things. And effectively what we're doing is, whether it's in the existing virtualization environment or in OpenShift virtualization, or OpenShift really using Calico, we're creating what is effectively a router. Right? So we're talking to that upstream router and saying, hey, I'm a part of the network. I am responsible for these IP addresses. I'll let you know when to send me traffic. And so by doing this, we make it kind of we're just using the natural features of BGP to make it much more hands-off. So that as the OpenShift administrator, as the virtualization administrator, I just go in and I create a VM, or I create a pod, or I create a service, and Calico handles putting it on the network and telling the rest of the network how to get there. So it makes it much more seamless in that regard of I don't have to worry about my routing rules for VLANs and the subnet assigned to those VLANs and all that other type of stuff. It's all handled, I'm going to say magically, knowing that magic is the bane of every administrator's existence, because if it works by magic, then we don't understand how it actually works. But
Yeah, the great thing about using BGP, as you said it, is that when you establish BGP, you're basically trying to tell these two environments how to get to each other. And that's about it. Now, in your BGP configuration, the network team can do stuff that helps you. For instance, here, I'm using the service cluster IP in the example to just say, I also want my service IPs that I create in Kubernetes to be propagated to the other place, to the other environment. And you can mix and match. You could say, I just want pods from this IP pool or this CIDR. Everything that you have in a router, in a BGP router, you also have here almost. And that's about it. Like you basically trying to connect these two environments together. So when you use an IP address anywhere, it can get to the other part, making the life of your application developers and other teams easier. They just come to you, say, get the BGP routing enabled and done. That's about it.
Yeah, and so VJ asks, so Calico works as an abstract layer, which I think you're asking is Calico an SDN? And my understanding is it's not. We're actually using the native network stack, right? We're not creating an overlay network. It's communicating directly on, layer 3 with the underlying network. But I might be wrong there.
So yes and no. It does some of the stuff that you would see in an SDN, but it does much more. The beauty of it, it usually uses the embedded networking stack from the Linux, and it it just routes stuff in some sort of layer 3. It just sends an IP route. It just injects an IP route in your kernel, so the pod knows where to get to, the VM knows where to get to, and if you want to talk to that pod or VM, when you come to the kernel, it knows where is the route. Now, why did I say a little bit? Because there's not just one data plane that we use. The standard data plane that uses the networking, the Linux networking stack. We also offer eBPF and other data planes. So yeah.
And just to be clear, but we're not that, let me think of how to phrase this, that communication, so from pod to pod or host to host, is not happening across, for example, a Geneve tunnel. It's yeah, okay. So it's still the native network, but Calico is coordinating, connecting everything together and saying, hey, we created a new pod with this IP address, and it updates the relevant routing tables, so that way everybody knows how to get to all of the things that it needs to.
Exactly.
So it's an abstraction, but not an overlay.
Exactly. Now, that being said, getting back to the demo, after you created your AS number, then you need to create a peer. Now, the peer is your other environment router. It's their identity and their IP address. Now, there are much more configurations that you can add. We will add a little bit here, but after you do this, as you can see, the BGP will be established. Depending on what sort of environment you have, you might need to go in and change or tweak a couple of things. Here, because we have a multi-hop scenario, these two boxes that we see are connected, are inside a cloud. So basically, we need to create some sort of way to hide our IP addresses or internal IP addresses from the cloud gateway, because the cloud gateway doesn't know about the internal IP addresses that we are using in this scenario. Now, that being said, as you can see, everything is done through the networking stack, as Andrew pointed out. Things are getting added to the routing table, and here, because of the multi-hop, it is unreachable. Now, what we're going to do is we're going to add a couple of tweaks here. One is I'm going to say keep the next hop. So when you establish BGP, you can have the next hop as you can preserve the next hop. And I'm going to say where to send this traffic. So which is reachable by. Reachable by is the gateway that I'm going to use. And I also want to have a route reflector sort of scenario. So I just want one of my nodes to communicate with the other environment or the old environment. As you can see, the BGP will reload. Here we have to wait because it was a recording. I just killed the bird process, and as you can see, everything is working. I do have a routing entry in my table, and ping works. So basically, we establish communication, and my WordPress is working. Now, that being said, for a second, I thought this is a live demo and something is gonna, break, but it was a recording. So next to stop is gonna be questions and answer about this topic.
I think for me, and the key takeaway, and I know we want to be sensitive to time. So the key takeaway for me is we can, just like we have been doing with virtual machines and existing virtualization solutions, we can do the exact same behavior of delegating access to the network and control of that to the platform instead of having to
Yes.
manage it at multiple levels. And
Yes.
importantly, because OpenShift is still OpenShift, even when we're doing it with, even when we're using virtual machines in OpenShift, it works with pods just as well as it does with VMs, which I think
Yeah.
is really cool, right? A lot of folks will ask about, hey, how do I expose my pod-based application, directly to the rest of my network? And this is one of the ways that you can do that. Without something like, and please correct me if I'm wrong, without something like Calico, right? Within the OpenShift world, we're talking about something like Metal LB or a route or something like that. Whereas Calico brings all of that functionality as well, and adds
Yeah.
a bunch of other things on top.
Correct. I would add on top of that, in a migration scenario, usually people tell you, all right, like migrate something and you would have some downtime. With this scenario, when you have the BGP, you don't actually need to have a downtime. You just create the identical virtual machine in OpenShift and just connect it, see if it works. If it doesn't work, you will figure out the problem, you will solve it, and when you are ready, you can migrate as you would. Anyway,
Is it,
I was gonna say, I think the clever thing here too is that with BGP, you're using language that like network administrators and network engineers they use today, right? Like you're talking about neighbors and peering and setting up the ASs and stuff like that. So it's like you're actually incorporating the same language and knowledge that they already have, and you're putting it on this layer that now that they're not being obsoleted like some people probably think that they are when you start implementing things like this. So it's a pretty clever approach to it. I like it.
yeah, 100%. There are no new wheels that we are creating. We're just using the stuff that you already know. Just we're rolling it in a little bit a different way. But anyway, so after you got your VM and communication ready, then there comes this sort of, all right, this sense of security. You need to have micro-segmentation. You need to embed security. So in OpenShift, when you have Calico, uh, Calico creates the networking, and by default, everything is permitted. Uh, this behavior changes when when you add a policy. Now, what is a policy? A policy tells you if an intended traffic is going to flow, what action should be imposed to it, and you can say this intended traffic can be identified from this source to this destination or vice versa, depending on how you are trying to write your policy. And a policy is just another manifest with a kind network policy or global network policy, depending on what you want to do. So the intended is usually annotated with a namespace or a selector. Now, just to make these more relevant to a virtual machine era, a selector is similar to saying, I want to create a firewall rule that only allows these IP addresses to flow. Now, in OpenShift or Kubernetes, you cannot really work with IP addresses because they are ephemeral. They will be deleted and created again and again. And you usually don't know, while it is possible, you usually don't know what IP address is used by a VM. So what you can do is you can actually add labels to stuff. Now, that being said, um, it's not that it is impossible to use IP addresses. It's just a little bit different. You can certainly go to your VMs and set a static IP address for them. This is something that Calico provides, but if you like to make it a little bit modern, you could use labels. It will make it a lot easier. Now,
I'll point out that. Sorry, I'll point out that labels make it sort of policy based, right? In that it
yeah,
doesn't matter, right? I create one selector, right? We see here color equals red, and now this rule will apply to anything that matches that label, whether there's one database server or 1,000 database servers. They all automatically get that rule as they are created. And
Yes.
as you were pointing out, we don't have to know or care about the IP address. It's
Yes.
applied at the platform level. I think you said earlier that it uses nftables in order to enforce those rules. So, low level, Linux functionality that's, being applied and protecting, or if not protecting, at least allowing or denying access to those resources.
Yep. That is the beauty of it. You just create a label and it will enforce that policy to all the things that have that label. So next, you would say, what sort of action? So in Calico, you have different actions. You can say allow, deny, or pass, depending on what you want to do. These are self-explanatory other than pass. Pass is usually used to send a traffic from a tier to another tier. A tier is just like a folder. You can create one folder that has everything for your security team and another tier or a folder for your database team. And these teams may or may not be able to change policies in each tier, depending on what you want to have or what sort of permission you give them. Anyway.
That's cool.
Yep. And after that, you are in the, and after that, you have to say, all right, this traffic is a TCP traffic that is coming from this source to this destination. Now, the source and destination, you can use labels, you can use IP addresses, you can use things like networking cards, which is usually not possible with Kubernetes network policies because that doesn't extend to stuff that are not namespace. So you basically can say anything that is namespaced or non-namespaced, similar to forking cards, some host processes, sockets, those sort of things. And after that, you can have a policy. Now, that being said, let's get back to the virtualization era. Now, when you have a VM and you want to get, let's say, to an external IP address like 1.1.1.1. Now, the thing that happens there is the VM usually uses a networking VM NIC and tries to use your virtual switch to get to the physical networking card in your ESX. Now, that being said, I'm taking out the NSX part, but for the most, NSX does something similar. The virtual switch has a little bit more sauce on it, but that's about it. So what happens is your VM tries to talk to an external IP. It goes to your VM NIC, and it gets to the external network. Now, the same thing for OpenShift is the same scenario. When you have OpenShift and VM can happen, but if you have OpenShift and Calico, you don't need to write two policies for each places. What you can do is you can actually use the universal micro-segmentation. So the policies that you create can be enforced in your virtualized environment. That being said, in a normal scenario, your VM was literally talking to whatever it wanted. Now, what you can do is you can add a Calico agent to your virtual machines or to your golden template images. And that Calico agent will sync with the Calico mothership on the OpenShift and figure out if your VM is allowed to talk to an entity or an external IP or an internal IP, and it will enforce the rule that you have created, the policy that you created, and either drop or allow that traffic. Now, there's a video. Is there any questions, by the way?
Just for me. But yeah, so and I just want to make sure that I'm understanding this correctly. So with this universal policy, I have VMs and pods, and I say, hey, I want all of my VMs and pods in my OpenShift environment and in my VMware environment to be able to talk to whatever, let's say, directory services, right? So like DNS, maybe a satellite, some other like provisioning server, whatever, right? I can set up a universal rule that says allow all of these clients, pods, VMs, whatever, in whatever cloud to talk to that. But then if I want to go to maybe like the portal for Red Hat, block that. Is that kind of how that universal role would work? That universal policy, or is it more between cluster to cluster?
So let me phrase it that way. The stuff that you have in your OpenShift are already protected with the policy that you created, right? Now, the universal part sort of means to me that if I create a policy in OpenShift, I want it to be enforced in my virtualized environment outside of my OpenShift, let's say VMware, right? So I don't go and create policies that don't sync. Like I have a database access on my virtual machine in VMware, but I have a different set of rules in my OpenShift. So what I can do is create the agent in virtual machines in the VMware, and I don't need to care about anything else because everything is going through OpenShift, getting synced and enforced.
Got it. Okay, I was thinking of it more like a firewall rule, but it's really between the clusters. Okay, yeah. Awesome.
So
Reza, one question I have is, so generally when people look at the VMware environments and everything and the VM admins and the people who have worked in that, they think they are proficient and very much focused towards the UI side of the world. But I know programming languages, right, to do the automated deployment of the VMs, policies, everything, and this network segmentation, it's extensively done there because they have like tens of thousands of VMs out there on multiple hosts, everything. So all this is like programmable as a code, things like that, as a part of their package, or do they need to go and do something different?
So while you can get to a terminal and write everything, Calico offers a GUI or a GUI that allows you to see what traffics are happening at any time, regardless of being a virtual machine or a pod, right? So these are inside OpenShift. If you create a resource inside OpenShift and it tries to access the network, you will see it in Calico UI, the service graph. That being said, if you have something in your old virtualized environment, VMware, then those are a little bit vague, right? What you can do is, again, having that Calico agent, figuring out what are the traffics that are happening in the old environment and shipping it to OpenShift, watching everything in the same place in the same UI. And in that UI, you can just go click on things and create policies. Now, I do believe I have it in the presentation here.
Got it. Okay.
Yeah. So again, same virtual machine, same OpenShift. It can talk to the MySQL. As you can see, the ping still works. Now here, my virtual machine can talk to both the internet and my database. Now, what I'm going to do is going into that Calico dashboard, using my token, go to policies, and basically go through the policies. So just a second, there are a bunch of policies that Calico creates by default. These are policies that we embed with Calico. These are all the communication that happens on a Calico level. So if you want to turn on some sort of zero trust, you don't need to be worried about what is happening to your Calico. Everything is already set for you. You just add the stuff that you need for your own environment. Now, there are two ways to do that. I'm getting there a little bit slower than usual. So, all right. So, creating a policy, as I said, the command line way is always there, and after you do it, for some reason it goes back. Wait a second. All right, here. So after you create a policy from the command line, it will pop up in your UI. Vice versa, if you create it from UI, it will pop up in your command line. You can reorder stuff, which can change the priority. In each policy, you have stuff on the right top side. These are all the traffic that your policy captures, if it's allowed, if it's denied, if it's passed. And there are rules that you can have for the selector. I'm just going to get to the part that we checked the policy. As you can see, the policy drops the traffic for both places that we want to get, sort of forcing isolation on that VM. You can go to the service graph or the policy recommendation to change these behavior and have the policies there. Now, that being said, any sort of questions?
Nope.
So that being said, when you have BGP, it's a little bit difficult to isolate different networks. This usually happens in a multi-tenant environment where you have a couple of tenants, each have their own enterprises, and you are connected to these private networks. Now, for this scenario, you could use network policies, but network policies makes it very difficult to manage this sort of dynamic scenario. Now, an easier way would be VRF isolation. So by default, when you have Calico and you establish BGP, your cluster is connected to all the networks that you embed the BGP for. Here we have two tenants. Each tenant has an enterprise network on their own side, which should be private and not be viewed by the other tenant. Now, normally, because everything is allowed in OpenShift and Kubernetes by default, unless you write a policy, a tenant who's our tenant A can access their own private network and the private network for the other tenant, tenant B. Now, what you can do is you can actually use a feature of Calico called Egress Gateway. Egress Gateway allows you to create a new gateway for your VMs and pods. And this gateway will enforce routing policies to those pods and VMs. So basically, we are taking out or ripping our routing table into 2, 3, or 4 and designate each VM to those routing tables. So when tenant A tries to go through to get to their own network, it will go to its immediate gateway, which is the egress gateway. It will figure out if they're allowed to connect to that network. If they're allowed, it will permit it. Now, the same if the tenant A tries to communicate with the private network of tenant B, then the egress gateway drops it because they don't have access to it. And that's about it. I do believe there is a video that is all right. So let's 10 minutes. So that's a little bit.
We can jump in.
out there.
I know you
Yeah,
have.
it's
I know you have a hard stop.
yep, it's a little bit out there, but anyway, just to show you.
And
So each
just-
tenant.
I just wanted to say for background, VRF, virtual routing and forwarding, I believe, is what that stands for.
Yes.
It's, I think it originated in the telco space, right? Of
Yep.
basically separate routing, separate routing tables, separate traffic paths, right? Kernel level isolation for networking traffic. So
Exactly.
yeah, handy when you have, project A, namespace B. They're running on the same hosts, they're communicating with each other, but there's like host level separation, kernel level separation between their network traffic, even though it looks the same.
Yes.
Exactly.
Yeah. And it was a hard requirement, and it came from the SDN side of the world when people started to put like outsourcing their entire data centers to telecom operators.
Yeah. So basically, you create something called external networks, just a fancy way for Calico. You can see it on the left side. Just a fancy way for Calico to create a routing table inside your Linux machine, Linux host. Then you create egress gateway, assign it to that external network, as you can see on the left side. And after that, we add IP rules with higher priority to intercept or hijack those traffic and send it to that routing table to be to go where they need to go. Now we create a pod, an egress gateway pod. As you can see, they will be added again to the routing table of your Linux and Linux host or OpenShift host. And when you have virtual machines, you can label those virtual machines, as you can see here. Where is it? Here. You can label them with the external network, and then those VMs will be again injected to the routing table, and the default routing table of your host will get an entire different sort of view, which all other VMs that are trying to communicate with those networks cannot. And that particular BGP route will be injected to the, let's say, table 500, as you can see on the right bottom side. And anything that is sort of added to that routing table will be allowed to communicate with that routing table. Any questions?
We did have a question from VJ of, and I don't know, Reza, if this is you or Dheeraj, but how Calico helps with stateful workload migration from virtual machines to OpenShift. And I think I want to tweak that a little bit of, because there's two aspects. So there's one that is moving virtual machines from, existing virtualization platform to OpenShift virtualization. And the other one is more of an app modernization thing, which is my application is running in a VM today, and I want it to run in a container in Kubernetes tomorrow. So I think in both cases, my answer would be the same, which is effectively we're abstracting, to use whoever asked about that earlier, we're abstracting the networking pieces away, so that from the perspective of the application and the things that are connecting to it, we're utilizing the same tools. We're able to easily direct traffic to the new location without having to go through a bunch of rigmarole, if you will. But I'll let y'all expand. You're far more knowledgeable than I am.
So that's a big claim. I don't think I can take it, but from what I understand, when you're trying to migrate, the actual migration, Calico doesn't do anything in that space. We're just trying to create the networking and security that you would require when you have your migration. That being said, if you have some sort of workload that requires high availability and needs to be always connected, what you can do is you can use the BGP to have the communication ready. You can create a replica of, let's say, your WordPress, not a database, your WordPress in the other environment, in the OpenShift environment. Since you have the BGP, you can go to your gateways that are allowing consumers to come in and sort of change that to go to the new VMs on your OpenShift machine. Now, that being said, you have no downtime. If it's stateful, the people who are already connected to your old environment will still be connected because that is your load balancer sort of turf. And any new customer or consumer that comes in goes to the OpenShift. Now, that being said, there are cookies here to sort of figure out those sort of things. If people are logging, and you could use Redis, those sort of technologies. But again, we sort of help you with the networking and security layer. Some of the stuff you might need to go through and figure out if they're applicable to your own environment or your use case.
So, Reza, one thing I want to say is definitely during migration, it's the networking we provide, but in the day two operations also, right? Like when you have newer applications coming, newer VMs being moved around, Calico basically becomes your networking fabric within OpenShift virtualization, correct?
Yes. So when you have Calico or when you install Calico in OpenShift, every sort of networking thing happens within Calico.
I just realized I've been sitting here with my mute off. I don't know if y'all can hear the high-pitched whine that is happening in the background. I don't know what it is, but I hope it's not coming through.
Nope, I can hear it.
Good. So I know I have a hard stop here in just a couple of minutes. Reza, I think we had discussed that you also have a previous commitment that I am very envious of yours. Please enjoy your afternoon activity.
I'm not gonna miss my shot. So I have to go take my shot.
That's right, absolutely.
Yep.
So we'll close out the stream and answer any questions with Dheeraj, and then anything that we can't get answered, we'll be sure to follow up. Thank you so much for your time today. Really appreciate it. And I think this is the, I don't know, 4th or 5th time that I've seen you go through all of that. It's still amazing to me. Like, I've been doing networking for 20 years and I'm still like, it's still got a little bit of the magic to me of like, I don't know how that works, but that's really awesome. And so I'm always just delighted and surprised every time I see y'all do that. So
great. Always a pleasure. Thank everybody who tuned in to hear what we have to say. If you want to reach us, Tigera Slack or the Red Hat team, they are always there. You could reach us in LinkedIn, Slack, those sort of things. And thank you for the time, and goodbye.
Yeah, thanks, Reza.
Have fun, man.
So with that, as we said, only a few minutes left. So anybody who has any questions, please don't hesitate to put those into chat. We'll do our best to get to those before we close out the stream here in just a couple of minutes. That being said, as always, if you're not watching us live, if you think of something that comes up after the fact, please don't hesitate to reach out. Jonny loves to get emails, Jonny, Jonny at redhat.com. I also redirect all of my emails over to Jonny at this point. So just stream related or not, they're all going to Jonny going forward. No, I'm kidding. Please, of course, feel free to reach out to me, Sully, Sully at redhat.com, and we will do our best to get those answered as quickly as we can. I do see a question here from Fayez. Apologies for butchering names. Isolating production and development environment VMs running on the same OpenShift cluster. Was that something discussed today? I was not here for quite some time. So I think there's a couple of different ways you can approach that. One is how how much isolation do you want? Is the natural or the normal isolation that happens in OpenShift enough from a resource protection perspective, from an RBAC perspective, all of that? I think where Tigera Calico really comes into play is at the network level, right? Where at the platform level, the administrator or the application owner can go in and define rules, micro-segmentation network policy rules that say namespace A cannot communicate with namespace B under any circumstances. And you can take that even further through VRF and create completely isolated networks that those two things cannot, even if they're on the same hosts, even if they're directly adjacent to each other, even if they have overlapping IP space, they're not able to talk to each other at all. So I think it's one of those, it's a yes and is my answer there of yes, we did talk about that, maybe not directly, but there's a lot of features there and it just depends on how far you want to take it. I'll default to you, Dheeraj.
Yeah, and I think so. You were spot on. So the use case 2 is basically the foundation of what has been asked, right? Like you have production environment, you have dev environment, test environment. So our micro-segmentation will help you do that categorization or isolation, and coupled with VRF, it basically starts to tighten that posture. The same thing can be applied when people are looking from the angle of team A not talking to team B, not talking to team C. Third way of looking at is if you have some type of in production environment, your database are PCI compliant or is a regulated workload sitting somewhere, and not everyone can talk to them in an architecture which you are building, micro-segmentation starts to apply there also. So yeah, our micro-segmentation basically helps you do environment-based isolation, team-based isolation, tenant-based isolation, you name any type of isolations you're looking at it. The policy framework works across the board, and then it's deployable as a policy, as a code, like when you are doing all this CI/CD pipeline type of deployment for your VMs, for your environments. Calico basically applies all these policies in the play, and as your VMs will move around within the OpenShift virtualization, the policies will always remain there attached to them, and it will follow the rule to keep you compliant.
Yeah, policy-based and attaching it to labels is amazing because it like you said, it follows it around. I as the administrator, I don't have to know or care. It's just automatically there.
Yep. Worked out well for us. Another thing I wanted to add was there are 2 links which we have posted here. Jonny, if you could share, as I don't know the mechanics of the platform. One is the of the solution brief of Red Hat Partner Connect, where basically we have talked about how the joint solution should help with respect to all the networking and network security pieces of this environment of yours. And the second one is we have created a self-paced workshop, instruct workshop, so that team can go in and then for like half an hour or so can try it in a curated environment, this entire experience of these use cases and see how it will benefit them, and then just follow along by asking us questions and things along those lines.
Awesome.
Posted them for you. All good.
Yeah. Thank you very much for coming on, for joining us today, Dheeraj. Reza, who just left, thank you as well, in case you ever go back and listen to this. But it's always, like I said, I've seen y'all do this multiple times now. We did a webinar and all of that other stuff, and it's always fun to me. I always enjoy seeing this, and it's always, I'll say, exciting to see all of the really cool stuff that we can do and the capabilities that are being added to OpenShift and OpenShift virtualization by extension are just really incredible. I'll put in a plug again for if you missed the roadmap presentation, we call it a what's next presentation, but it's the roadmap. If you missed the roadmap presentation that happened Monday, definitely check that out in the OpenShift YouTube channel, because there's a lot of really cool stuff happening. Somebody asked me about it, and they're like, "Oh, what's happening?" Like everything is either virtualization centric or AI centric. Like that's the way that they kind of bucketed everything in there. And like, yes, of course, it benefits lots of other things in the process, but it's all like this is how feature X is enabling or otherwise improving capabilities for virtualization and or for AI type workloads. So lots of interesting stuff. And, of course, all of the other teams, Jonny and I did the what's new for admins. The developer team will do what's new for developers, right? All that other stuff. All of these things still apply to developers and all of that, and or admins, and everybody will put that into context. But the PMs are thinking about it in context of those things. Anyways, thank you again. Thank you so much to our audience for joining us today. Jonny, what do we have coming up?
Yes. So next week we have Veeam Caston coming on, and then that's on the 11th. And then on the 18th we have Turbonomics coming on. So going to be a pretty cool couple weeks coming up with partners.
Yeah, Turbonomic. I'm interested to see what they have to say as well, because they're I'm familiar with them from back in the VMware days and when I was a virtualization admin. So I'm interested to see what they have to say with regard to OpenShift and OpenShift virtualization. So
yeah, and actually both of those are thanks to Peter Lauterbach. He made the introductions while we were at KubeCon, and met Mike from Veeam, and then Eva from Turbonomics, and it sounds awesome. So it's gonna be cool to have them come on and see what it's about.
All right. Well, thank you so much, everybody, and we will see you next week. Jonny, any last thoughts?
Hey, Diraj, thanks a lot for coming on. Really appreciate your time, you and Reza. And it's cool to see how far Calico's come. When I first started with Kubernetes, I used Calico way back in the day. So I like to see it progress and evolve and get better and better. It's really cool to see. So, and I'm happy for you. So thank you very much.
Thank you, Jonny. Thank you for the note, and thank you, Andrew. Thanks for inviting us on this podcast. Definitely, we enjoyed all of it, and looking forward to working on many more things with you guys.
Awesome.
Thank you.
Thanks, y'all. See you next week.
See you.